Welcome back to our virtual labs, and this is for Chem 120 General Chemistry online labs. And today we'll be doing Lab 5, Stoichiometry and Mass Percent of Commercial Vinegar with Baking Soda. Okay, so a couple of changes here. First of all, this pre-lab question, this is back when we were trying to actually do it together and that didn't work so well. It's just a recording now, so you do not have to submit them early. Just with the lab. All right, so first of all, it asks about if we begin with a reaction of 100 grams of matter, then we must end the reaction with 100 grams of matter. Discuss this in terms of the law of conservation of mass. What I want you to do here is I want you to explain why the first sentence is true using the law of conservation of mass as a guideline. All right, then our second part here is to use your ion list and your periodic table to find the formulas for these four things. I do not want you to look them up. Instead, I want you to use your ion list here, as you were taught in chapter 2, to determine them. And I'm actually going to help a little bit. By now, you all know what carbon dioxide is, CO2, okay? And now here we have sodium acetate. So this is based on the sodium ion and the acetate ion, C2H3O2 minus, okay? Now you need to balance these and come up with the overall formula. And the same thing, we have sodium bicarbonate here, and this is the sodium ion paired with the bicarbonate ion, HCO3 with a 1 minus charge. Okay. And now here we have acetic acid. And see this ic? Remember that ic comes from 8. Okay, so this would be acetate. The acetate ion is C2H3O2, and in order to make it an acid, we need to add a proton. And now you need to put these together for that. Now, after you have come up with these formulas for part 2, or part A, I guess, you're going to take the formulas that you've come up with and come down here to find the molar mass for each reactant or product. I don't want you looking these up. I want you finding them out. So in this lab, I want you to specifically show me what we have. Our carbons mean we have one of them in carbon dioxide, and that's 1 times, now from the periodic table, 12.011. And oxygen, there are 2 of them in carbon dioxide, so 2 times 15.999. Now it looks like I'm not looking them up, but I've got my periodic table right here, and I just have some of them memorized. But you would be finding them, for example, there's carbon and oxygen, and this is the periodic table that you were supposed to print. And when we combine these, okay, we get 2 times, here, let me put this here, 2 times 15.999 equals, okay, plus 12.011, and I get 44.009. grams per mole. Okay, now I want you to do that for the rest of these as well based on the formulas that you determined in part A. Okay, now we'll go ahead and turn this over and we can see the lab. Now I'm breaking my own rules here in that I have baking soda that's already open and vinegar that's already open. And so the interesting thing here is, well, why should you use brand new vinegar and brand new baking soda? And the reason for that is twofold. Number one, baking soda could absorb moisture and from the air, and so there's a potential that this, let me turn it around, that this isn't pure baking soda anymore, that it's baking soda with a little bit of water in it, and that would make it a little bit, that would make our results potentially off. Now, the reason that you would ideally want to use new vinegar is that the old vinegar, the acetic acid in the vinegar will evaporate over time. So these are fairly new. They're only a couple of months old, and I guess the reason that they're here is that I really did not want to purchase new baking soda and new vinegar, because I purchased them new for the last time I did the lab, and now I have a lot of baking soda and vinegar in my house. So, but that might introduce an error. Okay, now the next part here is this is what is the balanced reaction for our lab? Well, we're looking at baking soda, which is our sodium bicarbonate, NaHCO3 solid, okay, and this is our baking soda. And vinegar, and that is acetic acid, HC2O, oh, sorry, HC2 H3O2 AQ. So that means aqueous. So this is our vinegar. Okay. Now, when we mix these together, we get bubbles, lots and lots and lots of bubbles. And those bubbles are CO2G for gas. I'll write bubbles under here. And we'll get what's left in solution, and that's, so here we've got CO2 coming out of here. So one oxygen, one hydrogen, and one hydrogen come together to make water. And what's left is a sodium acetate, NaC2, sorry, H3O2, and it'll be aqueous. Okay. And these are all a 1-to-1 ratio, and this is what's going to be happening in our lab. Okay, so let's go ahead and begin. Okay, first of all, it tells us to weigh out between 12 and 14 grams of baking soda, and then it asks what mass of carbon dioxide could we produce assuming 100% yield, and that's going to be stoichiometry. So this is a really, really great lab for examining stoich. Okay, so the first thing that I'm going to do actually is I am going to weigh out my beaker, and I can see that it's 20.5 grams. So I'm just going to make a note of that here. I might need that later, and so having it will help. Okay, now what I'm going to do is see this T button, I'm going to tear it. And now I'm going to take my baking soda and I'm going to add between 12 and 14 grams. Okay, so here I have 13.4 grams of baking soda, and I'm going to keep track of that over here as well. So 13.4 grams, and that's the baking soda, so it's NaHCO3. Okay, now I'm going to start by setting this aside, and I'm going to think to myself, okay, well, let's predict our possible yield. Okay, so predict theoretical yield. And we're going to do that with stoichiometry. So we start with our given, and that's 13.4 grams of sodium bicarbonate. Hopefully while you're watching this, you have already watched the lecture videos and for stoichiometry. If you haven't, you're going to wish you had that. If not, you probably need to go back and look. Okay, so now we have the molar mass of our sodium bicarb, and that would be 82.034 grams of NaHCO3 per mole. Oop, Na. Why I always work in pencil. Okay. And the next thing that I need in my stoichiometry is a mole ratio. And so we have our baking soda and we're looking for our carbon dioxide. So our known is our baking soda, and there's 1 mole of that. And we make 1 mole of carbon dioxide. Okay. And now we'll finish it out with a molar mass of our carbon dioxide. So we have 1 mole of CO2, and I did this on the other page. You guys watched me do that, and that's 44.009 grams CO2 per mole. And now you can see, okay, I can cancel grams sodium bicarb with sodium bicarb, moles sodium bicarb with moles sodium bicarb, moles CO2 with moles CO2, and I'm left with grams of CO2. So this means now that, all right, so I'm trying to see around my hand here. Okay, so I have 13.4 divided by 82.034 equals, okay, and basically I'm just leaving out all the ones, all right, and then times 44.009. And what I get is 7.19. Okay, so 7.19 grams of CO2. This is my theoretical yield of carbon dioxide. And I'm going to keep that in my head for later. Okay, now it says what mass of acetic acid will we need to react with our baking soda completely to get 100% yield? Well, if you read the introduction, you would see that 5% of our vinegar is acetic acid. Okay, so what that means is, okay, so we need now to figure out how much vinegar that we're going to need. Okay, based on a molar mass. Okay, all right, so with this, what mass of acetic acid will we need to react with our baking soda completely? What this means from our 13.4, now we need to also, I'm going to come down here, we need to do another stoichiometry to figure out what mass of acetic acid we're going to need. Okay, so I'm just going to kind of put this in parentheses here, and we'll come back to it later. So now we start this stoichiometry again. We need 13.4 grams of our sodium bicarb, NaHCO3, times, and this stoichiometry always starts the same way. We have our known here, 82.034 grams per mole. Okay, times, now all of these are 1-to-1 ratios, so we have 1 mole of our NaHCO3 to 1 mole of our acetic acid, HC2H3O2. And now in order to determine what mass of vinegar we're going to have, we need the molar mass for our acetic acid. 1 mole HC2H3O2 like this. Okay. And up here we'll have 60.052 grams. Okay. So this means, okay, so now I'm going to type this into my calculator. 13.4 divided by 82.034 equals times 60.052 equals, okay, and I get 9.81 grams of acetic acid. C2H3O2. Okay, now I'm going to come back here and see, but only 5% of this is our acetic acid. So what we need to do is, I'm actually going to set up a proportion because I think that'll be pretty easy here. 5% is acetic acid, 9.81, okay, and over 100, and that will give me the mass of my vinegar. And the way I solve this is 9.81 times 100 all over 5, it's that cross multiplication of proportions, equals the mass of my vinegar. Okay. And so I'm doing 9.81 times 100 divided by 5, and that gives me 196.2 grams of vinegar. Oh, goodness. Okay, so do you see what I did here? All this, sorry about that. I got ahead of myself. No wonder I had no space. This was supposed to go right here. Sorry about that. Okay. Okay. Oh, I need to sit down. Okay, so I apologize for that. This bottom section here should have been right down here, so you'll have more room when you do that. Okay, 196.2 grams of vinegar. That is what I need to react with my 13.4 grams of sodium bicarbonate. And if I combine those two together and the overall value loses 7.19 or 7.2 grams of gas, then I'll know that this is accurate. All right, so let me go ahead and come to page 3. Okay, so the next part of this is to find this. All right, now the last time I did this, I made a crazy huge mess. Okay, so I'm coming over here and I'm zeroing out a little beaker. Oh dear. I don't know that I'm going to be able to get 196. I'll do it in pieces. We'll do, okay, so we need 196.2 grams of vinegar, so we'll have to do this in bits, which is just fine. Okay, 96.4, and we needed 196.2. So I'm just going to come over here and make a note that the first one is 96.4 grams vinegar. Okay, and now what I'm going to do is we're going to watch this. Now this, if you've ever seen like kids making you know, volcanoes in elementary school. This is what it is. So we have to do this slowly so that we don't make a big mess. And some of it's so that we don't make a big mess, but some of it also is because if it overflows, we'll lose a portion of it. Okay. Which is why it's okay that I can't pour all this in at once anyway. And you see the bubbling action. Hopefully you can see that really, really well. And you can probably hear it in the video as well. Let's see if you can. Oh, yeah. There we go. Lots of bubbles. All those bubbles are the carbon dioxide gas being evolved from the reaction. And they're escaping. You can see how there's no way I could have poured all of the vinegar in here at once, or whoosh, it would have just gone right overflowing. And even now I have to be careful that I don't dump too much in at once. Okay, now we remember that that was only about half the vinegar. So let me come over here and measure out the 100 that I need to go with that 96. Technically 99.8. Oop, okay, that was too much. Oh, 99.7. That's really close. We're going to call that good. We're going to round that with sig figs to exactly where I need to be. 99.7. Okay, if I put that together, I end up with 196.1. All right, that's pretty close. Close enough that we're not going to monkey around with it too much. Okay, now you can see this is sort of, you can see that there's still some baking soda in the bottom of this, which is why we still need some more. Well, let's take a look. And now I actually have a little spoon here that I'm going to use to agitate this. And what I'm doing there is I'm just speeding up the reaction. It's basically what stirring it is doing. Whoa. You can see how much the bubbles make the whole thing really rise. If you have a scale, you can do this as well at home. I know that not everybody does, which is why we're doing this virtually. All right. There. Now I have put in all of the vinegar. And while this reaction is finishing, let's come over here and do a little bit of a prediction. Okay, so remember we had that law of conservation of mass. So we had 0.1 grams of our vinegar, and we had 13.4 grams of our baking soda, And that means that our reactants equal 196.1 plus 13.4 equals 209.5 grams. Okay, well that means that our products also have to equal 209.5 grams. That's basically what the law of conservation of mass is saying. And that's how we can figure out how much carbon dioxide is produced, because the carbon dioxide is the only thing that's escaping this beaker. And it's still bubbling, which means that the chemical reaction is still occurring. I'm going to move my spoon. Okay. Now, remember that the beaker, remember over here, that beaker equals 20.5. So when I look for the mass of this, my beaker plus products is going to be 20.5 plus 209.5. Okay, which becomes 230.0 grams. And you notice that I am keeping all of my significant figures here. All right, so now I come over here, and I don't know if you can see this. Do you see all the bubbles in there? I want to make sure that those bubbles go, because those bubbles are carbon dioxide, and in order for this to really work, I need to eliminate that contamination. And one of the ways that you can do that, I don't know if you can see what I'm doing, but I'm basically just sort of tapping it on the table to get the bubbles to release. Okay, and I'm gonna stir and agitate again. And again, the only reason that we stir is to increase the rate of reaction. If I wanted to sit here, I could just sit here and it would slowly complete its reaction over lots and lots of time. But as long as I am causing bubbling with my stirring, the reaction is still occurring. And now you can see more bubbles that have sort of formed. And I want them all to escape. Okay, that is pretty good. Okay, so I'm going to go ahead and turn on my scale. Give kind of final taps. And now I'm going to set my beaker with my reactants on my scale. And I get 223.1 grams. Let's come over here. I'll just write it right here, 223.1 grams. Okay, and now what I do is I say 230 grams minus 223.1 grams, and this will equal my mass of carbon dioxide. Okay. And right now I'm getting 6.9 grams. So that means that I'm a little bit low, which makes sense because remember we talked at the beginning about that. I'm going to see if I can, maybe that I went too quickly, and I'm going to see if I continue to agitate it for a bit. Perhaps there's still some carbon dioxide in solution. I'm trying to get the carbon dioxide to come out of solution, you know, sort of like when if you leave a soda lying around for a day and then you come back and it's flat. And the bubbles will eventually just come out of solution, but sometimes it can take some time. Okay, let's see if the kind of aggressive stirring that I was doing has made more of this evolve. It has. Look at that, 222.8. So, oh, 230 minus 222.8, and we have now gotten 7.2. Okay, so that means that our vinegar, and that's what we had expected to get, 7.2. Okay, and I really had to work for that, that extra amount. So my guess is there's probably isn't any more. So we're gonna go ahead and just skip this. Okay, and you need to write a conclusion here. Okay? Let me know if you have any questions.